In this video, we'll take a look at systems of equations and how to solve them. For section 5.2, the systems of equations, we're going to solve by graphing, and then in section 5.3, we're going to solve the systems algebraically using substitution and elimination. So the first video will do this first problem, a system of two linear equations, looks like, usually an x and y, looks like the following. In this video, we're going to solve those equations in three different ways. And then we'll make another video taking a look at the rest of notes. So a system of equations means, in solving a system means, find a solution that makes both equations true at the same time. And there are three different ways to do this. The first one, we'll take a look at graphing, so you can see physically what that looks like. So we're going to take each of our equations, x minus 3y is equal to 2, and 2x plus 5y is equal to 15, and put those in slope-intercept form so we can take a look at the graph. Solve for y, we'll subtract x from each side, we get negative 3y equals negative x plus 2, divide by negative 3, we end up with y is equal to 1/3 x minus 2/3. I've already got these graphed over on the right. So the first line, the y-intercept is negative 2/3, so that means y-intercept is here, and our slope is 1/3, so if we count up 1 to the right 3, that's where that line came from. All right, second line, let's go ahead and solve for y by subtracting 2x from both sides. We get 5y equals negative 2x plus 15. Divide both sides by 5. We end up with negative 2/5 x plus 3. So that's our second line with a y-intercept of 3 and a slope of negative 2 down 2 to the right 5. So these two lines intersect at a coordinate 5, 1. So we can write the solution as the coordinate 5, 1. That means x equals 5 and y is equal to 1 is a true statement for both of these equations. To check, take a look back at the original. Let's substitute 5 in for x and 1 in for y. So 5 minus 3 times 1 equals 2. 5 minus 3 is 2. That checks. 2 times 5 plus 5 times 1 is equal to 15. We get 2 times 5 is 10 plus 5 is equal to 15. So that's a solution that works in both. So we're going to take a look at the same system and solve it algebraically. Graphically is great when it crosses somewhere that's a coordinate that you can see, but many times they don't cross at a nice easy coordinate like 5, 1. All right, so solving by substitution. Steps in solving by substitution algebraically are: number 1, solve one equation for one of the unknowns. So we have x and y in two equations. Choose the one if you're going to use this method. If you have something all by itself, like that x, substitution is a good method to use. So step 1, I'm going to solve this equation for x by adding 3y to both sides. So I get x is equal to 3y plus 2. Okay. Step 2, substitute the solution into the other equation. Okay, so the other equation is 2 times x, but we're going to substitute what we have for x. 3y plus 2 plus 5y is equal to 15. So the reason we do that is so that we can have an equation in one variable. Okay, now step 3, we're going to solve that resulting equation and find a value for y. So use distributive property. 2 times 3 is 6y plus 4 plus 5y is equal to 15. We end up with 11y plus 4 is equal to 15. Subtract 4 from each side. 11y equals 11. Divide 11 from each side. We get y is equal to 1, which agrees with what we had before, which is good. Now step 4, substitute this value, y equals 1, into the equation of step 1. So we have x equals 3y plus 2, so we're going to take our answer for y and substitute it. And we end up with x is equal to 5. So our solution again is x equals 5, y is equal to 1, or the coordinate 5, 1. And step 5 is to check. We checked that previously, so we know that that works. So that's a second way to solve a system, but the first algebraic. The second algebraic method is something called elimination or addition or subtraction. Okay, so you might have learned it as elimination, and I'll write it down. So we have write the equations in the form, if they're not already in this form. I included the form here. You get your x's and y's on one side equal to the constant on the other. Then I call it elimination because what the goal is we want to multiply all terms of each equation by a constant so that the coefficients of one unknown will be numerically the same in both equations with either the same or different signs. I'm going to try to make sure we have different signs so that when we add the equations together, something cancels out or is eliminated. So if we look at the system of equations that we have, choose something that you want to eliminate. I have an x and a 2x, and I can multiply an equation by any number you want. If that were a negative 2x, these two would cancel. So what I'm going to do is multiply the entire equation by negative 2, and that's okay because in solving equations, we can multiply or divide by whatever we want as long as it's the same on both sides. So we end up with negative 2x plus negative times a negative 6y is equal to negative 4. I'm going to rewrite the second equation. I haven't changed that. Now I'm taking this multiple of the first equation and I'm going to add it to the second equation, and what we wanted to happen is a variable was eliminated. So the x's are eliminated and I'm left with 11y is equal to 11. Divide both sides by 11. We end up with y is equal to 1. And then this time take your y coordinate and substitute it back in one of the two original. So I'll use the first equation, x minus 3 times 1 is equal to 2. Add 3 to both sides. X is equal to 5. So those are 3 different ways that you can solve a system of equations, and that's the first half of this video.